Okay, so this last unit on logical reasoning, I was just saying informally before I started recording, two outcomes. One, you have to be able to do set theory. We're going to do 3 sets of notes on set theory, and they're all actually relatively short and simple. The fourth set of notes is on puzzles and games. Pardon me, you guys are actually, for 3 days next week, we're going to let you play board games for a little while because it's actually one of the outcomes it suggests to do. This would actually be a typical diploma question. Actually, this first little slide I've got right here, it's under the puzzles and games category. So why don't we give this one a try here? What it's saying here is that if this shape plus this here was added to this shape right here, it's saying it would make this one right here. So then the next question is, well, what would happen if this shape and this shape were added together? What would it be? Would it be this one, this one, this one, this one, or this one? There's 5 choices here. Which of the 5 choices is it supposed to be? That's kind of like an example of a question they might ask you. So let's let this one be A. This is B. C, D. Apparently there's 5 choices here. There's E. Do you guys kind of get what I'm asking you here? One of the things that kids either love or hate about this section here is, again, there's no work to it. You just look at it and you go, well, that's the answer, right? Which one do you think it is, Ben? D, the fourth one here? All right, so let's walk through the idea here. If you took this one right here and you superimpose this one on top, you would have a line that would go straight, oh, I suck at this, a line that would go straight down. You'd have a line that would go on a diagonal, and then that one would come through there, and that's what this one here looks like. I'm going to change my orientation. So right here, I need to draw the box that came from right here, and I need the diagonal to go through, which is, yeah, that one's D. Does that make sense? That's the sort of thing that's one of the 2 things you have to be able to do. Easy enough? One of the challenging parts to that then for us as teachers is I have no idea what in the world they're going to ask as a test question, but they're going to give you some sort of puzzle. Hence the whole thing where we're actually going to play board games for a couple of days. So, okay, before that though, I have to show you your logical reasoning, your sets notation. So if you do have this the formula sheet, it's this section right here. It's not hard, but you have to know what each of these 5 terms means. So there's A prime, a 0 with a line through it, like an upside down U, a C, which is actually like a sideways U, and then a regular U. I'm going to show you those over the next few slides. So let's walk through some notes here. In terms of terminology, we use the word set, and a set basically just describes a collection. Okay, if you have objects, you call it a set. For example, you guys are the set of 30-2 students. Make sense? Everybody in this classroom is a 30-2 student. Everybody who is not a 30-2 student is somewhere else. That makes sense? Each individual item then is called an element. So using that same example, you and 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 you means we have 9 elements today. Does that make sense? So I've got this silly example right here of hockey players. I took a dig at my own team here. You'll catch it here. So I mean, some words I could use is let the universal set. Universal set basically means everybody we're going to consider. Okay, so everybody that's under consideration is hockey players. We could call those N, and I said there's 600 elements because in the NHL there's 600 players, give or take. Right? A subset could be everybody playing for the Vancouver Canucks. A subset then is like a smaller grouping of it. So I'm going to label those as V, and so Vancouver has 20 players on them. Another subset of that could be the goalies, and so then Vancouver has 2 goalies on their team. That makes sense? Okay, here's where I took my dig at this here. An empty set then would be all of the Vancouver Canucks in the playoffs. I leave this up year after year. It always works. Anyways, because you guys get the idea here, is that there are no Vancouver Canucks in the playoffs. So in terms of that notation off on the side wall right there, empty set, if you ever see this symbol right here, it doesn't necessarily mean, it's not just a 0. It means that there are no elements in that set. Okay. Let me give you a different example other than the hockey one. If you guys are all sets of students in our school, if I were to ask you in this classroom, the students who are in grade 5, that would be an empty set because we don't have grade 5s, not even in our school. Does that make sense? Okay. So this right here is a symbol I need you to know right here. This symbol right here means intersection. I can't point to the word that's over here, but you guys can see that right there, intersection. This symbol right here is what happens when you try to find where sets overlap. So if I were to ask you, tell me all the players that are on the Vancouver Canucks and on the Calgary Flames, Well, you can't be on the Canucks and the Flames. You're on one team or the other. Does that make sense? So the word we use for that is disjoint sets, where those are things where if I were to draw a Venn diagram, here's the Calgary players, here is the Vancouver players. Is there any overlap in the middle? No, because it literally is one or the other. We're going to work with Venn diagrams a lot today. This is disjoint right here. It actually kind of makes sense. Disjoint are these two circles joined at all? No. Here they are joined, but this would be if somehow you could have Calgary and Vancouver players, but you can't. It's one or the other. So here's some more definitions and terminologies for you. So universal set is everybody under consideration. I think this is the important words here. Because it can't be every single thing in the universe. Does that make sense? Like if I asked you about how many students there are, well, we're not going to count the kids at like random schools in Hong Kong and Malaysia, right? Like, so we have to like define it down to at least what we're considering. So like I could say the universal set could be everybody in our school. That makes sense? A subset is a grouping of that. So like a subset of kids at Walsh could be the grade 12s. Makes sense? It's a subset. Okay, here's vocabulary that maybe you guys didn't hear in the last section or learn. It's called the complement. I think I've talked with a few of you guys about this before. A compliment in math doesn't mean you look really nice today. A compliment means the opposite. So if I were to say the subset is everybody in grade 12, the complement of that is everybody else, which would be your 6s, 7s, 8s, 9s, 10s, and 11s. Does that make sense? Or if I were to have a subset being all of the girls, then the complement of that would be all of the boys. You know what I mean? Like it's the opposite grouping. Okay. An empty set would then be like a physical impossibility. So again, if I were to ask you, tell me about the set of grade 5s at our school, you would then say there aren't any. The way you represent that is with this 0 symbol right here. Disjoint sets have no overlapping elements. So if I were to ask you, how many kids are there that are in grade 10 and in grade 3? There aren't any kids that are in grade 10 and in grade 3. You get what I'm saying? I might be able to find some kids that are in grade 11 and 12 because maybe there's a grade 12 kid taking a grade 11 course. Does that make sense? So like maybe you could argue that. Okay. And then here's the one I haven't mentioned, an infinite set. There are some sets that are actually impossible to count because they just keep going and going for forever. I'll give you an example. An infinite set could be all of the natural numbers. Do you guys know what natural numbers are? What are the natural numbers? 1, 2, 3, 4, 5. Whole numbers that are positive. Oh, so I mean, I start listing them off. 1, 2, 3, 4, 5. Are there more than that? 6, then 7, then 8. So if it's the kind of set, and this doesn't happen a lot, but if you have the type of set where like you can just always keep going, it's an infinite set. Any issues on the vocabulary? Okay, I think you guys are going to find this easy. Let's do an example here. Really, really simple one. Let's let every province and territory in Canada be our big universal set. We're going to call that C. We often use letters to represent these. So the first thing I want us to do is list all of the elements in the universal set of Canada. Here's how you might write that out then. This is the way we notate this. If C stands for Canada, they often use like curly shaped brackets. You guys know the ones I'm talking about here? And then we just start listing them out. So I'm going to go west to east. You've got British Columbia. You've got Alberta. You've got Saskatchewan, Manitoba, Ontario, Quebec, New Brunswick. I'm going to have to start a new side here. New Brunswick, Nova Scotia, PEI, Newfoundland and Labrador. Then we need the territories. Those are the Yukon, the Northwest Territories, and none of it. And that's how we would notate this. It's not hard to do. You literally write everything out and you put it in curly brackets. So there's all the provinces in our universal set of Canada. If I were to ask you this notation here, NC, the answer is 13. Let me take a stab at how the heck I just pulled that out of the air. The number of elements in the Canada set is 13. Because that's what I was doing as I was pausing. I was adding them up in my head. Okay. So if you ever just see C by itself or A or whatever letter they pick, you write it in curly brackets. If I write NC, you don't tell me what they are. You tell me how many there are. Easy enough? Okay. Well, let's try one of them here. We're now going to talk about a subset, the Maritime provinces. You guys know what the Maritimes are? Which are the Maritime provinces in Canada? Yep. PEI, Newfoundland and Labrador, and New Brunswick. Yeah, those are known as our Maritime provinces, if you didn't know. I don't even know why we call them Maritime provinces. You guys knew this though, right? You didn't know this before? Yeah, fair enough. You weren't born here. We call those our Maritimes. So all I would do is I would use a capital M, and then using curly brackets, I would say that Nova Scotia, Prince Edward Island, Newfoundland, what did I miss? New Brunswick, those are our Maritime provinces. And if it asked me N, capital M, then there'd be 4. That makes sense. It's super easy. I just need to show you like the way in which it works. Okay, last one here. What would M, we use a little colon, like a little dash next to it here. We call it the complement. What would M prime or M complement be? Everything but. So if I had to write it out then, just to be redundant here, M complement then would be, N for it would be 9, you're right. But if I actually had to write them out then, it would be BC, Alberta, Saskatchewan, Manitoba, Ontario, Quebec, don't count that one. Okay, skip ahead to Yukon, Northwest Territories, and none of it. Okay, and if I asked you for N of M prime, then you'd say there were 9 of them. Is that really straightforward? That's basically it. I've taught you the lesson. Okay, now, I should show you a few more examples. I wouldn't be doing my job if I didn't give you a few more variety of examples, but that's it. That is the concept for the day. So, but I should give you some more examples just for practice. Because again, I said this earlier, my biggest struggle as a teacher preparing you for the diploma is I don't know exactly what they're going to ask about. They could ask about provinces. They could ask about, if you looked at the assignment, I put one on there about musical instruments. You know what I mean? Like, there's too much variety. So, here's some notes just kind of showing you how to notate it. The idea is you put it inside little brackets like this. Another way that you can write it, by the way, is that if something is a subset of something else, you write it like this. I didn't show you that one. Let me go back a slide here. The way this would work here is that you could have said that the Maritimes are a subset of Canada. That's this symbol. You know how I have it on the board written in pen right here? That one that's right over there that I can't touch because it's outside the screen. Okay, this means the Maritimes are inside the subset of Canada. You could write that notation. Okay. If I were to ever give you something impossible, by the way, you either write the 0 symbol, or another possibility is you literally write brackets and you put nothing inside, which is kind of ironic. It's like B is, brackets, right? The silly example here was here's the numbers 1, 2, and 3. And then it said here, okay, who has the number 4? Well, the number 4 is not 1, 2, or 3, so that's why it was an empty set. Does that make sense? Okay, cool. Moving on. I have like a silly example of how this gets worked in everyday life. Narrowing things down actually works like this. You guys ever watch those crime TV shows like CSI or This is Criminal Minds? In a way, imagine that this was kind of the scenario here. First, you want to figure out everybody who made a cell phone call, like nearby. Okay, so there's like 8,000 people who made a cell phone call. But then you narrow it down to somebody who also works in a factory. Well, now we're down to 27 people. Then they have to be someone who drives a truck. Well, that narrows it down to 8 people. Then it has to be somebody who lives in a nearby neighborhood. That narrows it down to 3 people. Then it has to be someone who's male. That narrows it down to 2 people. You get what I'm saying here? Like, it's that same sort of thing where you got this big diagram and you're sort of narrowing it down one at a time. Okay, let's try another one here. Let's let S be all of the numbers from 1 to 100. Okay, I don't want to write them out because that would be crazy. So if I could, I just want to do this. Let's let S be 1, 2, 3, dot, 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 99, comma, 100. Does that make sense? That kind of implies that we're writing them all from 1 to 100. Okay. If I were to ask you to write out the multiples of 5 or 10, you could write it something like this, like multiples of 5 would be like 5, 10, 15, 20, and then like going on the other side, it would be like 90, 95, 100. There, those are all the multiples of 5. I don't care exactly how they ask you to notate this, but I just went M5 for multiples of 5. If I asked you for all the multiples of 10, what would those be? Until you got to like 90 and 100. What if I asked you for the number of multiples of 10? Yeah. Because counting them out, there's 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Okay. Now, when I ask you how many there are, do not put it in brackets. I want to make sure everybody sees this. This is super important. You guys catch this? If I ask you how many there are using this n right here in front of it, do not put that in brackets. Because then this, in brackets, assumes it's the number 10. You get what I'm saying here? As opposed to that there are 10 of them. So don't do that, okay? That'd be a big mistake. Big mistake. Okay, let's move forward here. Here's another silly example here, but that's honestly most of the ones in this unit are silly. A is all of the animals in the world. W is all the warm-blooded animals. C is all of the cold-blooded animals. B is your birds. M is your mammals. What we want to do is I want to start using some set notation to describe how these things work with each other. So let me show you a few ones first here. I could say that warm-blooded animals are part of animals. Does that make sense? What this means here is that all of your warm-blooded animals are animals. Does that make sense? I could even say that all of your cold-blooded animals are animals. I could say that mammals are part of warm-blooded animals. All mammals are warm-blooded. I could even say all birds are warm-blooded. I'm going to write a wrong one here, though. Would this be fair to say? Are birds part of cold-blooded animals? No. So this would be an incorrect statement. Okay. I could write something like this. I could say mammals and birds are the empty set. Think this one through for a second. How many mammals are there that are also birds? Did this guy right here and this guy right here, did they overlap at all? So what I'm saying here is any mammals that intersect with birds, see again on the side right here, that intersection symbol is this one right here. There are no mammals that intersect with birds. So this is the empty set. There are none there. Okay. So you might be asked on a diploma question. They might give you a whole bunch of statements. Like say this could be answer A, this could be B, this could be C, this could be D, this could be E. They might ask you which statement is true or not true. All of these statements were true except for this one. That was a false statement. Okay, let's try another example here. Like I said, I'm just trying to show you variety today. This one here says a triangular number is a number like 1, 3, 6, or 10. And the reason why you call it a triangular number is because you can literally make it into a triangle. Right? Like see how I have 3 dots? See how there's a triangle out of them? Here I have 6 dots. You can make a triangle out of it. Here I have 10 dots. You can make a triangle out of it. So the question here kind of combines that logical reasoning portion of it. We have to figure out how many numbers from 1 to 100 are going to be triangular. So clearly the number 1, 3, 6, and 10 are, because it gave us that pattern. What's the next one going to be? How'd you figure it out? Yeah. what you got to do is add 4. So now we're going to add 5. So the next number will be 15. Okay, let's keep going. 21. No, 28. Because you got to add 7. Then we need to add 8, which gives us 36. And then we had to add 9, which gives us 45. 10, which gives us 55. 11, which gives us 66. 12, which gives us 78. 13, which gives us 91. And we run out of numbers because we said to go from 1 to 100. So like a common diploma question might be, they might give you this scenario, and they might say, list all the numbers. Or they might say, how many numbers are there? In which case you'd say there were 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. You'd say there were 13 of them. Okay. To save time right now, I'm not going to write out all the ones that are not triangular. Yeah, that's how many there would be. If I asked you how to notate this, if this was T, then this would be T with a little like dash next to it, and that would be everything that's not. Does that make sense to you? Well, if I wrote N T dot, then there would be, sorry, hang on. If I wrote NT, the answer would be 13, because that's how many of them there are. But if it just asks you T by itself, it literally wants you to list them all, which kind of sucks, because sometimes you want to write them all out, right? Okay, one last example here. How many of these numbers are even and triangular? 6 is even. 10, 28, and 36, 66, and 78. Does that make sense? Here's how you might notate this. This would be numbers that are even and are triangular. This symbol right here, it's called an intersection. You know how we talked about and versus or in our probability unit? This is basically the symbol for and. You have to have even and triangular. You need them both. Here, the way I remember it is that this right here kind of looks like the letter A if you put a bar across the bottom. The one that we haven't covered yet is this one sitting over here. U stands for union. This one means or. And I remember that because then it's kind of like an O. It's silly. But this symbol here, the intersection, means add them. This union one here means or. So anyways, I don't know, it looks like eat. Okay, anyways, the even and triangular ones then would be 6, 10, 28, 36, 66, and 78. You guys cool with that? It's kind of easy stuff, isn't it? Yeah. We saved the easy unit for Christmas. So, honestly, congrats. You guys made it through the hardest part of Math 30-2. Like, this is the, I don't want to call it the gimme section because I hate it if you don't get it, but this is the easiest section. Okay, let's try another example here. You've got two four-sided die. S is all the possibilities. I'm just going to write them out here. You've got a 1, a 2, a 3, and a 4. And then you've got a 1, a 2, a 3, and a 4 on your two dice. So you could have 1 with 1. You could have 2 with 1, 3 with 1, and 4 with 1. You could have 2 with 1, 2 with 2, 2 with 3 with 2, 4 with 2. I'm not being consistent here, am I? 3 with 1, 3 with 2, 3 with 3, 3 with 4, 4 with 1, 4 with 2, 4 with 3, and 4 with 4. How many possibilities are there? Cool. Okay. So use set notation to describe the rolls that sum to more than 5. So I guess I could write it as like sum to 5 plus. I don't know. Sum to 5 plus. Which ones had more than 5? This one here. So the 4 with the 2. The 3 and the 3 will do it. Pardon me. The 4 and the 3 will do it. This 4 and 2 will do it. So that's like the other 4 and 2. Then the other 4 and 3 will do it. And then the 4 and 4. Again, if I were to then ask you something else, if I asked you the number of dice that sum to 5 or more, then you would say there are 6 of them that do that. Easy? Sweet. Okay, we're done. That was topic 1. Easy enough? Anybody have their assignment printed off? Here, let's answer a few questions just informally as a group here. If you don't have your assignment, grab a sheet of paper here. I want to do the first 2 questions with you because we have time today. We have lots of time. I got 45 minutes left. I hadn't thought that through. Probably the first one should be due like next week Friday, and then the second one should be due the following week Thursday probably. So don't write it down just yet, but like you guys can have a week to work on it still. We're only just starting. Okay, I'm not going to write this down. I'll talk it through with you. So if you guys want to write it down here, there's not a lot of writing to do here. So here's the scenario. You've got 12 different instruments. Here's the instruments. So the first thing I want you to do here is list all the elements of sets K and S. Okay, so first K is everything that has keys on it. So what you should really do is write out a K, capital K, equals sign, and then do a curly bracket. And then now we got to start writing out any of these instruments that have a key on them. So does a piano have keys? Write the piano down. Does a recorder have keys? It has like little holes that you put your fingers on, but is that a key? Okay, then don't write it down. Does a violin have keys? Nope. Does a trumpet have keys? It has those little valves you push down on. I guess that's kind of a key, isn't it? Okay. Bagpipe? I think they do. Because they have like little buttons you press to change the notes, I think, right? It's like a trumpet. Are they holes? Is it holes? Okay, then don't write bagpipe down then. Never mind. There's a little bit of interpretation on this one. Yeah. An accordion has keys. Accordions have keys because it's got like a full piano on one side. Does a flute have keys? Are we counting those as keys then or no? Are buttons a key or no? What did we say for trumpet? Does a trumpet have keys? Okay, if we count a trumpet, we should probably count a flute then, I guess. Because whatever you press down on a trumpet, you press the same kind of thing on a flute. Okay, does a drum have a key? Does a guitar have a key? Clarinet. I guess if a flute and a trumpet are considered to have keys, then clarinets do. Xylophones definitely have keys. Because all the little pieces you play on there are each a key. And then a banjo. Okay. Okay, so that's set K. And then set S is everything that has strings in it. This one's a little bit easier to figure out. Does a piano have strings? Actually, it does. Because the strings are inside the whole part of the piano, right? Like how you press the keys down, right? But like the whole big rest of the piano has strings inside of it. Yeah. Recorder? No. Violin? Yes. Trumpet? No. Bagpipe? No. Accordion? No. Flute? No. Drum? No. But like the way an accordion works is you squeeze in and out, and it has like a little keyboard on the side that like changes things, but I don't think it has strings inside of it. Yeah, because what the keys do is it changes how the air goes through the squeeze box. So, guitar though, guitar has strings, and banjo has strings. Okay, so at least on this example here, I literally need you to write them all out. Okay. The next thing I want you to do is write a Venn diagram, and I'll actually physically go to the board and draw this out here. Now that we've figured this out, you already have some experiences with Venn diagrams. There's 4 locations in a Venn diagram. There's this only, there's both, there's this one here, and then there's neither. And we have to write each of these things then in a Venn diagram. So why don't we make this be keys? We'll make this be strings. This will be both. This will be neither. So let's start labeling. Where's the piano go? Yeah, both, because piano had both. Recorder, what do we say for recorder? Nothing? A violin, strings, but strings only, right? Trumpet, we said yes to keys on that one. So trumpet. Do you guys feel like you kind of get what I'm going for here? So you guys can do the rest of this later. Okay, now for C and D, the hardest part about this is you have to understand what I'm asking for. K, this symbol S. What is this symbol right here? And, okay? What is keys and strings? Yep. So for this one right here, you're literally going to write out the word piano. This right here says how many things are like that. And so then just one. Yeah, because the piano's the only one that does that. Does that make sense? This one gets a bit more challenging then. This one right here asks you for K, U, S with a little asterisk next to it. That's a little bit more hard to, you have to actually talk it through. So what does the U stand for? Okay, so we're looking for everything that's in either K or S. I'm going to use the word prime. That's the math word we sometimes use to describe this little symbol here. So K or S prime means find everything in keyboard or strings, and then find the opposite of that. You know what I'm really asking for here? The complement. So if you're either in the keys or in the strings, but then you're not in either of those circles, I'm actually asking you for neither. Yeah, this notation right here is a fancy way of saying neither. Because what this means is you're either a keyboard or a string, but then the prime means you're not a keyboard or a string. So which were the things that were not keyboards or strings? I only got as far as writing recorder. Bagpipe, drum. But yeah, so the first one here you'd have to write it all out, and then here you'd have to tell me how many of them there are. Does that make sense? Okay. Oh, why don't we leave that there because I actually haven't shown you how to do E yet. But up till there, did that make sense to you guys? The hardest thing probably in this whole section is if they give you notation like this, can you figure out what they're asking for? So sometimes it's a bit of a mouthful because like this was K or S. So K or S means anything in the circle. And then prime means, well, then pick the outside of the circle bit. So if you can reason with that, you're good. Okay, why don't we go on to our next set of notes here? And then I'll come back to that question once I've shown you a bit more stuff. Okay, the next thing I need to work on then is actually, once we get our idea of sets, the next topic here is all about Venn diagrams. The good news is you guys have already done a little bit of Venn diagram work here. So I'm going to revisit a very basic question that you would have learned back with Mr. Bonnet earlier. It would look something like this. In an Alberta school, you have 65 seniors. Some of them play basketball, some play volleyball, some don't play any sport. And so here's your basic Venn diagram. Why don't I go with these ones be volleyball. These guys over here play basketball. You guys know what I mean by this, right? Like the middle is both, and then the outside is like none. You're going to be asked one of these questions on the diploma. I guarantee it. So you got to know how to solve one of these. The way I like to show you is go A, B, C, and D, and then start writing out some statements. Like, for example, it says there are 65 seniors. That means that everybody who plays just volleyball, everybody who plays both, everybody who plays just basketball, or everybody who is lame and does nothing is 65. Does that make sense? Okay, if 23 play volleyball, what does that mean? Not just A, because A is people who only play volleyball, B is people who play volleyball and also play basketball. Yeah, so A plus B is 23. So using that logic, how does the 26 work then? Good. B plus C is 26. And then it says 31 students don't play either sport. What does that mean? Yeah, D on its own is 31 because D is people who don't do anything. Okay. So our goal now today, which really you did this question before, hopefully. Okay, I guarantee you're getting one of these on the diploma. Is you need to be able to like reverse engineer this and solve for a question like, well, who plays both or who plays just one or the other? You guys remember what to do? How do you solve this? Yeah, that's basically the idea. You take like say A and B right here. This A and B right here is 23. D here is 31. So then 23 plus C plus 31 is 65. What's that? That's 54. I think C is 11. Can you guys do that in your heads? Do I need to show you that stuff? A and B right here is 23. D is 31. So by default, C better be 11. You need to start working backwards. If C is 11, then B better be 15. And then if B is 15, A better be 8. And then just do a quick double check, make sure everybody's correct. Does 8, 15, 11, and 31 actually add up to 65? Just do a quick check on that. It does? All right, so then last step. If I were to ask you who plays both sports, you'd say there's 15 who do. If I asked you who plays only basketball, that would be 11. And those who only play volleyball would be 8. What I want to do right now, though, is show you some other ways that we would notate this. Okay? So I'm going to go down a little bit here. If I asked you volleyball and basketball, the number of kids who do that, I would say it's 15. Okay, that's what this means. The number of kids who play both volleyball and basketball is 15. That makes sense, everybody? If I were to say the number of kids who just play volleyball, it would be 23. Because 8 and 15 adds up to 23. Here's a new one for you. The number of kids who do V/B. V/B is 8. What does the slash mean? V/B means the number of kids who play volleyball, but who do not play basketball. Okay? The total number of kids who play volleyball was 23, but that's because 15 kids played both. Okay? If you ever see this notation here, V/B, it means take all the volleyball kids, but if they play basketball, don't count them. So in a way, this means the number of kids who only play volleyball. How would I write the kids who only play basketball? I know the answer is 11, but how do I write that? V/V. Yeah. So these are the kids who play basketball but don't play volleyball. What if I were to ask you this one here? V/U/B prime. What'd you say? It's 31. Is that what you said out loud there? Yeah. Because what this means is we want the kids who play volleyball or who play basketball. Imagine I was shading this in. Here's the kids who play volleyball. Here's the kids who play basketball. I know that I'm shading some kids in twice. But then if I want the opposite of that, well, then that's everybody who I didn't shade, which would be these guys here. That makes sense? Okay. So again, my whole goal today is basically I need you to be able to use this sort of notation sort of thing and understand what the heck it's asking about. So I believe that's what my next slides are about here. If you ever have Venn diagrams, so long as they're not disjoint sets, you guys recall from a few minutes ago what a disjoint set is? What's a disjoint set? No overlap. Okay. As long as they do overlap, you've got 4 sections. You've got section A, the middle section, section B, and the outside section. So that's the whole A, B, C, D thing. Yeah, let's move on. You guys get this part. So this right here is the new one that I just showed you. It's A/B. The way it's supposed to be read is A minus B. So like A minus B basically says find everybody in A, but don't count the ones also in B. Okay. So here's the 3 ways you can have A/B. You could have A and B like this. It's actually not a Venn diagram technically. What you could have is everybody in B is in A. Okay. And then if I ask you for A minus B, let's say that there were like 25 kids here and 3 kids inside here. If all of A is 25, and B is 3, then A/B would be 22. Does that make sense? Because there's 25 kids who take A, but 3 of them take B, so then you'd subtract. Okay. It's possible they could be disjoint, but here's the thing. When these sets are disjoint, are any of the people in A in B as well? Oh, so really, in this case right here, A slash B is actually A. Because when you remove the people in B, they weren't there anyways, right? This is the most common one though, where it means then that you can't count these guys right here in the middle. You can't count them. So, well, let's try an example. I've got one down here of just some basic numbers. This, by the way, just talks about those other letters, but I think I've covered that already. So here's some basic sets. Tell me what A, this symbol B means. Okay, so we're looking for A and B. Which numbers are in both A and B? Does that make sense? Yeah, because the only numbers that are in both sets are 3, 4, and 5. Okay, let's go this way now. A slash B. A slash B means give me the numbers that are in A, but they can't be in B. That's these two. Does that make sense? Because 3, 4, and 5 were in B. They don't count. Let's do this one here next, just while it's there. Which ones are in B that are not in A? Cool. You guys get this. It's so easy, right? This one right here. What does this mean? A or B? Well, here's the answer. It's A or B basically means everybody. I know that 3, 4, and 5 are in both sets. Don't write them twice, though. Okay? Like if I ask you A or B, don't write it a second time. I know it was in both sets, but like this one right here is kind of like the comprehensive list of everybody. Easy enough? Moving on. Okay, I don't even know whether I want to write stuff down on this one here. More that I just want to like talk about the idea. You guys know your deck of cards, right? Hearts, clubs, spades, diamonds. We did this in the other unit too. If I were to ask you clubs, spades, hearts, and diamonds, how many total cards are there between all of those ones there? Do you guys remember how many total there are? Yeah. So I guess what I could say is that the number of cards that are clubs or spades or hearts or diamonds is 52. Does that notation make sense to you? The number of cards that are either a club or a spade or a heart or a diamond is 52. So if I were to ask you for the number, let's do it this way here, the number of spades or hearts, how many cards are there that are either spades or hearts? Say that louder. Explain yourself. Yeah. Or another way of looking at it is there's 13 spades and there's 13 hearts. Yeah. How about this one here? What about the number of S intersect H? There are none. How many spades are there that are also hearts? Now, if I asked you N, S, or H, you'd say 0. If I asked you for S or H, you could actually write it like this. There's the empty set. Literally, there is nothing that is both. Okay, this is one of the more challenging ones. These are the ones I need to work you guys towards then. S or H prime. What does this mean? Yeah, clubs and diamonds, basically, right? Because this means I want it to be a heart or a spade. And then I want it to be something else. So you're right, if I asked you the number of these, it'd be 26. But if I wrote it out here, what I'm actually asking you for is a diamond or a club. Because this means the hearts and the spades. This thing up here, though, means find the opposites of it. Cool. Moving on. Here's another big list one. What we're going to do is we're going to try to figure out, of all these sports here, there are some that involve a ball. There are some that involve some sort of racket or bat or some sort of hitting stick. Okay, hitting stick, let's call it. We're going to try to find, and for these ones here, just to keep it simpler, why don't we find the number of all of these, okay? Like, rather than actually write them all out, because I want to save you guys some space. If I actually asked you for BUR, you would write every single one of them out. Okay, but why don't we just save space? Let's find the number. So let's do these one at a time here. We may actually want to label these before we start here. Badminton. Does it have a ball or a racket and a bat? Yeah, let's say that it has a racket, and maybe it's not necessarily a ball, but maybe we could go with the birdie is the object you hit with it. So why don't we say this one actually has both? Okay, it has a ball and a racket. What about basketball? Ball only. Cross country? Unless you're really extreme and bring a baseball bat with you. Curling? Okay, but let's go with this is an object, and this is the object you hit it with. Okay, so let's just go with a ball then, I guess. I know it's a rock technically, but let's make it. Does that work? Okay. Football, just a ball. Golf. Yeah, you need a hitting stick and something to hit. Hockey, a hitting stick and something to hit. Lacrosse, hitting stick and something to hit. Rugby, just a ball. Skiing. You don't hit anything with the stick though. And even then, like that's only if you're talking cross country. I mean, if you're downhill skiing, you don't even have poles necessarily, do you? Okay, let's leave it blank. Soccer, softball, tennis, both. Frisbee? I guess, yeah. The frisbee could be like just a ball. You don't hit it with anything though. Volleyball, just a ball. Wrestling. Uh, Street fighting rules. Okay, we're cool on this one. So let's go through here. You're just waiting on it, aren't you? Okay, number of ball or rackets. So I would say there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 of these. I know some of them have both, but don't count it again if it's both, right? So 13 have either a ball or a racket. Oh, hang on. I did this wrong. What did I do wrong here? Yeah, if I put the brackets there, that's telling you what it is. So since I asked you just for the number of them, I shouldn't have put brackets there. Oh wait, which ones had both? Badminton, golf, hockey, lacrosse, softball, and tennis. I got 6. Okay, here's a challenging one. B and R prime. No. That one's this one, Jason. B and R means find all the ones that have both. And then the prime means find all the ones that are not both. So this one is not both. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That makes sense to you guys? But then this one is 3 because this is all the ones that are either a basket, a ball, or a racket. And then the opposite of those. So these are the ones that I've left blank. So this would be cross-country skiing and wrestling. Can you guys see the difference between the two here? Yeah. It's subtle, but that's where they're probably going to, if you're going to get caught on anything, it's something like this that you're going to miss. Okay, how many on here had a ball but not a racket? Basketball, curling, football, rugby, soccer, and frisbee? Basketball, curling, football, rugby, soccer, frisbee, volleyball. 7, right? How many things do we have on here that had a racket but without a ball? Yeah, I guess none. I mean, unless we ever decided to go with skiing, but that's interpretation. So I guess this one would be none. Yeah. This would be a good example of the empty set then. Because really, doesn't that make sense though? What sports do you play where you hit something, but you don't have a something to hit other than backyard street fighting, I guess? Okay. Let's try another one of these Venn diagram ones here. This is my last example, right? Sweet. 2 lessons done in one day, guys. I'm only 2 lessons in one day. Like, we still got 20 minutes left. Okay, so here's another common kind of example. You've got the 30 students. I admit the typo on here. In your math class. 18 ate breakfast. 5 who ate breakfast also ate a healthy lunch. The words, you gotta be really careful here. Then 3 students do not eat breakfast and do not eat a healthy lunch. So we're going to try to like piece this together just like you guys did in like the previous unit. So here's our overlapping section. I'm going to label these as, say, A, B, C, and D again. And as I label them, let's make these be the kids who eat breakfast. The middle is the kids who eat both breakfast and lunch. These are the kids who eat lunch only. And these are the kids who don't eat, apparently. each. It does happen. As far as I can go. Oh, I start with the 30. How can I write a statement involving the 30? Good job. Yeah, everybody better be 30. Okay, 18 eat breakfast. A plus B, yes. Because you need the kids who only eat breakfast, and you need the kids that ate breakfast and lunch. So 18 kids ate breakfast. Then it said 5 of the 18 kids who eat breakfast also ate a healthy lunch. What does that mean? This 5 of the 18, where would they be? They're in the both category. Because the 5 of the 18 kids who ate breakfast also eat a healthy lunch. We're looking for the people who ate breakfast and who ate lunch. That would be right here. B on its own is those 5 kids. Does that make sense? They did. In this particular example, they gave us B by itself. You got to go. And then the last thing it said is that 3 students do not eat breakfast and do not eat a healthy lunch. So if you don't eat breakfast and you don't eat lunch, where's that? Yeah, D actually. If you don't eat breakfast or lunch, what was that? 3 kids? So I mean, this example is a bit different than the ones you're used to because they actually straight up gave you B and D. So work at something like this. In this example right here, if you know what B is, put 5 right here for B, and then if B is 5, then you should be able to tell me what A is. A is 13. And then, yeah, you just got to work backwards here. If this is 13 and this is 5 and this is 3, then you said it was 9? Yeah, because 9 is the number that's left over to make it equal to 30. Okay. Now, to answer their question, though, now that we finally know what everything is, the question is, how many students eat a healthy lunch? Okay. So then, healthy lunch is actually 14, though. It's not 9. That makes sense. That's what everybody forgets, is they forget, well, hang on, you got to count the kids who ate lunch and breakfast, though, right? So 9 kids only eat lunch, but add on 5 more who ate breakfast and lunch. Yeah, because it said 3 students do not eat breakfast and don't eat a healthy lunch. So that's them. Those 3 kids don't eat at all. Okay, well, fine. Since we're talking healthy lunches, fine. Take off of the word. I get what you're saying. No, I mean maybe I should take off the word healthy. Maybe that's what's throwing you here. Okay. Maybe they eat lunch, but it's unhealthy. I guess. Yeah. Okay. Just take off the word healthy, just so it doesn't get confusing here. Okay. Okay. So we got breakfast, we got lunch, we got nobody. So I don't care whether it's healthy or not anymore. Okay, one more thing here, though. I wanna show you guys how to represent this in set notation, though. Well, then you would say that this would be the number of kids who had lunch would be 14. If I were to represent some of the other things we did, not that it was the question, but if I were to ask you, for example, number of L minus B's, what would that one be? Yep. If I were to give you B slash L, 13. Let's try one more, then we'll call it a day. The number of, okay, I'm going to go crazy here. Sorry, I want to change that. Okay, let's go a little nuts here. B and L prime and B not L. This is a little bit trickier once I start putting all these letters together. So let's talk through it once at a time here. Sometimes I actually find it worthwhile for kids to actually do some shading. So where is B and L? B and L, hopefully you'd agree, is in the middle. Does that work? Then I want the prime of it. So if we want B and L prime, it actually means I want this now, this, and this. So the red is now B and L prime. Sound good? And I also need it to be B not L. So where is B not L? Breakfast not lunch would have been just this section right here. So what is the stuff that is in green and also in red? I guess 13, yeah. It's kind of redundant. The red stuff was this one, and this one. The green stuff was this one here. The one that was in both of them is then just the 13. So you could be asked something a little bit more complicated like this, where you start to like add symbols on top of each other. I was just being silly with this one. So, any questions? Okay, so two things I need to be able to know. One of them is actually not new. You need to be able to do a Venn diagram, but that was old requirements anyways. The second thing I need to be able to do is know all these symbols. So know the prime symbol, know the empty set symbol, know the and symbol, know the subset symbol where something is inside of something else, and know the union symbol. Okay, and just know how to be able to like write those sorts of things. So, why don't we go back to that last part of the question I didn't finish, and then you guys can call her a day here, because I didn't actually finish this last question here. This last one here, if you guys remember the string instruments question, it said, if you want to determine how many instruments only had strings, what notation would be appropriate? So if I go back to the picture I have up here, how do I notate only strings? Yep, S/K. Only strings would be take all of the strings and then slash off the keys ones. So S/K would be the answer to this one. That makes sense? All right, cool. Okay, this assignment will not take you guys long, probably. So, I mean, get on it right away. The plan going forward from here, then, is we've got one more lesson. Bonnet's going to teach you, or I'll teach you on Monday. Tuesday, we're going to do an introduction to puzzles and games. And then Wednesday, Thursday, Friday, you guys and the 20-2s are going to play games for 3 days. So, do you guys know how to play, anybody know Blockus? Okay, I'll show you that one. Crib? Backgammon? No, that one's not on the list. I actually have a list of games. It's in the notes here. I'll find it for you. Of games that the curriculum actually suggests that we show you how to play. No, not that one. They suggest. Now here's the ones that I know how to do. So I can't do them all, but they like here's the outcome. You're supposed to be able to analyze puzzles and games that involve logical and numerical reasoning and use problem-solving strategies. They suggest trying these games here, but like they won't test you on them. So some of the ones we're going to learn are going to be how to do Sudokus, logic puzzles, magic squares, and rush hour. We'll show you how to play Crib, Battleship, Backgammon, Sequence, and Blockus. So we'll show you some of those games, and we'll spend 3 days playing them. So that's next week. You guys have any questions? You guys good? Okay, we'll see you guys later. You guys can take off, I guess.